Welcome to The Explainer. Today, we're unpacking the invisible, frankly mind-blowing mathematics behind our journeys into the stars. We're talking about the fundamentals of space dynamics. It's a topic that literally transforms how we understand motion, especially in one of the most extreme environments imaginable. Okay, let's dive into this.
You know, to truly grasp orbital mechanics, we've kind of got to throw our earthbound intuition right out the window. Down here on the ground, motion is all about friction, right? Tires gripping asphalt, engines pushing against air. But up there, in the vacuum of space, there is no air resistance. There are no roads. There's absolutely nothing to push off of. So once a spacecraft actually gains velocity, it can just coast on that momentum, almost endlessly.
Which naturally brings up a pretty massive question. If we strip away the roads, the steering wheels, and all that friction we rely on, how on Earth, or rather how in space, does a spacecraft actually know where to go? Well, the answer lies in space dynamics. It's the complex math of mastering forces and gravity in a total vacuum.
Section 1. The Secret of Orbits. Rethinking Gravity. To really get this, we have to rethink gravity entirely. It isn't just some force holding us down. It's actually the engine of space travel. Think about an orbit. It's not just a spacecraft floating around aimlessly up there. It is a super delicate balance. You've got the Earth constantly pulling the spacecraft down toward its center, while the spacecraft's immense forward velocity is trying to carry it straight ahead into the void. It's the precise combination of those two forces that creates an orbit.
Now, what's really interesting about this slide is the incredible reality it creates for astronauts. A spacecraft is actually constantly falling toward Earth, literally falling, but it's moving forward so fast that it just keeps missing. Imagine that. That continuous, rapid state of missing the ground, that is the exact magic keeping astronauts in orbit without crashing back down.
But hey, getting into that free fall, that's really only step one. To keep a multi-billion-dollar mission alive, engineers have to maintain absolute mastery over four fundamental dynamics. They are constantly, and I mean constantly, tracking the spacecraft's exact position, its velocity, its acceleration, and its precise orientation in the void.
Section 2. Two types of motion. Navigating the vacuum. Let's move to and see how this builds into how a spacecraft actually moves.
Tracking all those dynamics essentially boils down to solving two main questions. First up, you have translational motion. Simply put, where is the spacecraft physically moving from location to location? And second, there's rotational motion, which asks, how is the spacecraft turning around its own internal axes?
Section 3. Controlling the spin. Mastering attitude control.
This is where the engineering gets totally wild. Think about it. How do you turn a massive, heavy piece of metal in a vacuum when there's no air to push against? You actually don't need heavy external engines. Instead, engineers use incredibly clever internal devices called reaction wheels. By accelerating a heavy wheel inside the hull in one direction, physics dictates that the spaceship itself will rotate in the exact opposite direction. So the crucial point is, it's a beautifully elegant, completely fuel-free solution to steering.
But of course, reaction wheels aren't the only trick up our sleeves. Engineers also strategically place these tiny thrusters on the outside of the hull. A quick little burst produces just enough torque to subtly nudge the spacecraft's orientation. And whether they're relying on wheels or thrusters, this vital mastery of the spin is what we call attitude control. Section 4. The Celestial Choreography. Orbital Mechanics and Gravity Assists. All right, let's zoom out a bit. Imagine a spacecraft heading all the way to Mars. You can't just point the nose at the red planet, hit the gas, and hope for the best. It has to follow orbital mechanics. Engineers have to mathematically calculate the exact microsecond to burn the engines, the precise velocity required, and figure out how the massive gravitational pulls of different planets will dynamically warp their trajectory along the way. It's like a giant 3D game of chess.
And to cross these immense cosmic distances, we don't even need to run the engines continuously. We can literally weaponize gravity. By flying a spacecraft incredibly close to a planet, we can essentially steal a tiny bit of its orbital momentum. This drastically slingshots our velocity and changes our direction. This brilliant maneuver is known as a gravity assist.
Let me be clear, this isn't just some neat parlor trick. It is quite literally one of the most powerful ideas in all of spaceflight. By leveraging these massive planets, we can sling tiny probes out into the deepest, darkest reaches of the solar system, and we can do it without needing impossibly huge, heavy fuel tanks.
So you might be wondering, Why does all of this complex math and physics actually matter to you? Well, because space dynamics is way more than just textbook equations. Every single satellite communicating with your smartphone, every GPS signal giving you directions right now, every spacecraft actively exploring another planet, and every historic mission traveling beyond our Earth, every single one of them depends entirely on our ability to understand motion in space.
And this brilliantly illustrates the core message of today's explainer. When you truly grasp the mechanics, I promise you, you will never look at spaceflight the same way again. A spacecraft isn't simply flying aimlessly through some dark void. It is executing a breathtaking, carefully designed dance between velocity, gravity, forces, and time.
Space is, without a doubt, the most extreme environment we have ever encountered. Yet human ingenuity allows us to choreograph movement through it with absolute mathematical precision. So, are you ready to see the hidden math shaping our future in the stars? The next time you look up at the night sky, remember that silent, perfectly calculated celestial dance happening right above you. Thanks for joining me for this explainer. Keep wondering and keep learning.